Hi, it's Chuck Appleby again. We're here at our dining facility. It's been renovated this year. We spent around, I think, $12 million renovating the facility. A lot of new equipment, new plumbing, new heating system. With our contract, what we did is we have the contractor complying with all the code requirements. One of the things that they do is they collect a total coliform sample as part of their final commissioning of the building, but right before we get the building to use for our kitchen facility, which is then occupied by a contractor that runs the cooking operations. What we've done is we've included this facility in our drinking water system SOP, which includes copper and lead assessment in the drinking water. And today, we're here collecting the samples prior to the opening of the facilities to make sure that the plumbing work that was done in the building didn't contribute to any high-level lead. So we're going to show you how we collect those samples and how it affects the contract and turning on the contractor to come in and start cooking and prepping and able to feed all the troops.
Hello, I'm John Halligan. I work for Stockton University. I manage an environmental internship program with the Department of Military and Veteran Affairs. We go all over the state and we do environmental projects for the Environmental Management Bureau. One of the projects we do consistently is tap water sampling. We test for lead and copper from sinks just like this. Like Chuck said, this kitchen has been recently renovated, so we're going to collect 2 samples from this kitchen sink. One is the first draw before the sink has been used for the day, so it's undergone an 8-hour stagnation period. We'll collect that first sample, and then we'll let it flush for 5 minutes, at least 5 minutes, and then we'll collect our second sample. So I'll just run through that with you. This is the first draw. So you can see I let it run as if I was filling a glass of water. You don't want to run it just a trickle. You want it to be a representation of as if someone was using it for potable uses. And then we'll let it run for at least 5 minutes, and then we'll collect our second sample. Okay, well, it's been at least 5 minutes. We've successfully flushed the system, and now we're going to take our second draw. Okay, so we have our second draw sample. We've collected samples from 3 faucets in the kitchen. We've also collected samples from the boiler room spigot. That's the point of entry for the water system. So if any samples in the kitchen come up high in lead or copper, we have that sample at the point of entry showing that water coming into the building was clean, or if it wasn't, just for reference. Okay, so we're going to take our samples to the lab. We fill out our standard chain of custody form with all the different samples. It usually takes a couple days to a week to get results back, and then we communicate those results to facility personnel. If there are any exceedances, we'll come back and we'll put up signs, and then we'll try to identify the cause of the contamination. Could be a kitchen faucet fixture, just the fixture itself. It could be more involved. It could be plumbing throughout the building. So we try to collect more samples to try to trace where the contamination is coming from. The contract with the lab is very simple. We just pay by credit card. We pick up the bottles directly from them, and then we drop off the bottles whenever we need to, the samples whenever we need to. We don't need to schedule or reserve drop-off or anything like that. It's really simple.
Hi, it's Chuck Appleby again. We're here at our dining facility, and I wanted to go over a couple of different issues that we have regarding lead and copper in our drinking water systems. New Jersey has opted to go and sample all our facilities for lead and copper at various faucets and hose bibs in different areas at the structures to identify if there is any lead and copper and if there's an adverse impact to human health at those buildings. So we want to correct those things, of course, once we find they exceed any standard levels that are EPA or local state required. So right here we have a new sink that went in our facility. One of the things we wanted to stress is that we specify what type of sink to get. We give them a few options, but we try to gear towards made in the USA products. That tries to help us avoid any metallurgic problems with the faucets themselves, with any leaching of any heavy metals into the water systems. This one was all specified in the contract, and the contractor agreed to provide those, and we're really thankful for that. We didn't have to work with any equivalents or anything like that proposed by the contractor. That would be at a lower cost. So what we have is a few different systems of plumbing. So in a renovation project, we're dealing with the old plumbing in the building, and we're also dealing with new. So right now I'm going to take you to look at some older soldered fittings that are in a pipe chase in the building. As you can see, we're zooming over into the pipe chase, and you can see all this asbestos covered pipe. And unfortunate, but our projects aren't able to abate all the asbestos in the building. When we do these renovations, we're often left with a little bit. We do try to get that removed. But if you look close, you can see some copper pipe and some shiny metal, and that's basically the solder residual that's from the soldering of the joints and the fittings on the pipe. And a lot of the lead comes from that material. So in the new construction, we're often avoiding that by using different types of systems. There's PEX, which are a plastic type pipe with a special fitting system. And we're going to show you what we used here in this building in a couple seconds.
We collected our water samples, we brought them to the lab for analysis, and in about 5 days we got the results back. And we confirmed that there was an exceedance on this faucet. This faucet in the past has been used for filling large pots for cooking, but it's no longer in use. And we determined that the likely cause of the exceedances was the lead copper soldered pipes that are in the pipe chase in the wall back here. There's several other faucets on this wall that are tied into the same line. So our solution was to flush all the faucets that are on this wall, flush the entire building really well, and then come back and resample. So we sampled a week later, we resampled this faucet. We also, the one that had the exceedance, we resampled or sampled all the other faucets that are on this wall and tied into that plumbing. We also sampled some beverage filling stations, some water fountains, a coffee maker, and a few other faucets in here. Took them to the lab, got them analyzed, and determined that there were no more exceedances. All the results were below detection for lead and copper, so that was good. But if the building remains vacant for any amount of time and the water stays stagnant in those pipes, we'll have to come back and resample. So the plumbing in this wall that was the cause of the exceedances is going to remain in place. So if the building isn't used, if the water stays in those pipes for any amount of time, we'll have to come back and resample to confirm that it's all below detection. But for now, we have confirmation that all these faucets are good to use. They're all below the detection for lead and copper. And this is an example of how we used sampling to confirm, to identify a faucet that had exceedances, come up with a plan for addressing that exceedance, and then resampling to confirm that everything is good to use.
Hi, we're over here at our dining facility at Girt, and this is where all the dirty dishes come in from the dining facility. As you can see over here, we have an existing sink area that was here, and the existing faucet is here, and up top we have where the new construction came in, the renovation, and they used a new pipe fitting. This is a ProPress fitting, so this has no lead, it's not soldered, and it's just a gasket inside, a rubber gasket, an O-ring, and then it's crimped on either side. It's pressed with a special tool to make the fitting work. So this way we completely avoid any use of any lead in any solder products. And it's also quicker, and apparently it lasts a lot longer, and it's a much better product. Hi, we're still in the RTI dining facility, and we're here to show you the brand new grease trap. This is something we're really excited about. We have a system now that has a skimmer on it, and the grease will come out, and then be disposed of on a regular basis rather than having to do any monthly or annual or never maintenance on these grease traps. We've had a lot of problems with grease traps that were built in the floor in the facility. They rust out, they're not inspected on a regular basis, they don't function correctly, they're not cleaned, they're only cleaned when they actually have a problem. We try to get them inspected, but that hasn't worked that well for us. So we've adopted this new system now. We're going to see how it works in this facility. This is the pot scrubbing sink, so the most greasy, dirty pots and cooking utensils are going to be cleaned here, and the grease will go down the sinks and through the system and collect in here. There is a maintenance system that's here, and it's right here on this poster. And we're going to try to work with the contractor to make sure that they do enforce this and they do the work necessary to make sure this is a clean area. We're suspect that this is going to work really well because, again, we're dependent on people, and we're always seem to fail when we have to depend on a lot of people for doing different things. One of the other things with the commissioning of the building is to make sure the pesticide management plan is being upheld. So as we go around, we just wanted to make sure that our pesticide contractor is putting traps in where appropriate, and they're all throughout the facility right now, so we're all set to move in once we get the certificate of occupancy and all the little incidental checklist items are completed. This is Chuck Appleby. I'm outside the RTI dining facility. What we did want to show you today was the grease trap. So inside we have a sink specific grease trap, a skimmer. And then now outside we have an actual grease trap. This one is maintained by the facility, it's inspected regularly, and it's vacked out at least twice a year, sometimes 3 times. A lot of times they just respond to a problem and they don't do it, but you want to have it on a recurring basis if at all possible. Other than that, the system works well. We discharge to the local sanitary system. There isn't a septic system here, and we haven't had any problems at all. Hey, welcome back. I just wanted to summarize for everybody what we went over today. We're at the dining facility, which had a major overhaul, renovation done this year. It took almost a whole year, so the water was shut off in the building, and we added a lot of new equipment and a lot of new plumbing. So with that, we had to come back afterwards and we proactively collected samples. John went over all that, and then we got some exceedances, so then we had to come back and resample. The main objective I wanted to go over today was the fact that these sampling events aren't required. They're not regulatory required. What they are is a proactive way to be protective of health of the people that we serve on a regular daily basis. This equipment in here is all new. We want to make sure at the point of use, whether it's in the kitchen or it's out here where a water fountain is, that the water is tested and it's safe. And that's our main goal, to protect human health and the environment. In this case, we want to protect everybody that comes in here on a daily basis to make sure that they have healthy, safe water to drink and that there are no problems that come up. So what we do is we encourage you to go out and do the same. If you have a big project going on and this water's going to be shut off or there's some major pipe changes going on, why don't you just take that extra effort and collect some samples and make sure that everything is all safe and secure for everybody. It doesn't cost a lot of money. They run around $15 a piece, each sample. So you can do it, you should do it. So I encourage everybody to go out there and make sure at the point of use, all the water in all your buildings is safe. Thank you.